Welcome in Dark Core. The latest Hubble finds are mind-blowing. Just look at this newly forming giant exoplanet from the constellation Auriga that is 9 times the mass of Jupiter. What about this breathtaking image of a head-on collision between two galaxies collectively called Orb 143? They passed through each other, causing a giant triangular firestorm with thousands of stars bursting to life. But the telescope was able to capture much larger events. Its pictures changed astronomers' views of many secrets of the cosmos. Hubble even became a time machine, allowing scientists to look into the past of our universe. So what other astonishing images did the telescope capture? And how did one image made by Hubble change science once and for all? INTRO, to allow us to see deep space, the creators of the Hubble Space Telescope, HST, had to work hard. The need for an orbital observatory was discussed back in the 70s. Scientists wanted to get clearer images of deep space than those taken from Earth. Our atmosphere makes observations difficult by absorbing and distorting light. We're going to show you some more incredible images, but first, a little quick history of Hubble. In 1977, the US Congress authorized the construction of a space telescope with the help of NASA. They decided to name it after the outstanding astronomer Edwin Hubble. The most difficult thing was to make the huge observatory mirror. It was constructed of heat-resistant glass with incredibly thin but durable coatings, a layer of aluminum 65 nanometers thick protected with a magnesium fluoride layer 25 nanometers thick. The entire space telescope turned out to be nearly the size of a school bus. Its primary mirror has a weight of 827 kilograms, 1,825 pounds, and has a diameter of 2.4 meters, 7.8 feet. This mirror captures light from a space object and reflects it onto a secondary mirror 0.3 meters, 12 inches, in diameter. This smaller mirror was placed in the optical tube. It reflects light through a hole in the main mirror, forming an image in the telescope. From there it is sent to scientific instruments. At the time of Hubble's launch, there were 6 such instruments. These are wide-angle and planetary cameras equipped with a set of 48 light filters to highlight light spectra. The wide-angle one has a large field of view, and the planetary one made it possible to greatly increase the observation points. Another device, a high-resolution spectrograph, was designed to operate in the ultraviolet range. With its help, the telescope can see dim objects captured by a special camera. The high-speed photometer, HSP, can observe variable stars and other objects with varying brightness. And the fine guidance sensors, FGS, record changes in the position of the object. Scientific instruments were located in the tail section of the HST. Closer to the center, there are 6 gyroscopes designed for the telescope's maneuvers when pointing at an object. In addition, 4 reaction wheels allow the Hubble Space Telescope to change its overall orientation and catch a target. 2 main computers were placed in the central compartment. The first one is designed to give commands to the devices on board and transmit data to Earth. The other one has to control the guidance, gyroscopes, and other system functions. The telescope was also equipped with 2 wing-like solar arrays measuring 12.1 by 2.5 meters, 40 by 8.2 feet, each that convert solar energy into electricity. And part of this electricity powers the operation of the telescope. The rest is accumulated in the onboard batteries for the periods when Hubble is in the Earth's shadow. However, the telescope consumes an average of only 2,100 watts of power per day, which is about the same as 5 refrigerators. In doing so, it revolves around the Earth at a cruising speed of roughly 27,350 kilometers, 17,000 miles per hour, which results in one orbit every 95 minutes. In order for Hubble to always stay in touch with the Earth, 4 antennas were placed in the area of its wings. All information and commands are transmitted via satellites. Astronomers were thrilled for Hubble to be ready for the launch. Finally, in 1990, the Space Shuttle Discovery took off with the telescope, which weighed about 10,800 kilograms, 24,000 pounds. That's about as much weight as 2 full-grown African elephants. The ship safely delivered the heavy payload to a low orbit about 550 kilometers, 340 miles, above Earth. Shortly, scientists received the long-awaited images, and, instead of applause, they got back a bunch of blurry images. Hubble's large mirror clearly had an optical defect. There was an aberration 1/50th the thickness of a human hair, but that was enough to affect the clarity of Hubble's early images. Spacewalking astronauts fixed, maintained and upgraded the telescope during for-servicing missions. Hubble has been scanning the universe for over 30 years, and it has constantly surprised us because the telescope is about 10 billion times as sensitive as the human eye. Even though Hubble captures everything in black and white, scientists later transformed these images using a technique that mimics the natural perception of color by human eyes. Let's take a look at the most stunning of the million-plus images captured by the telescope. This is the Butterfly Nebula that lies between 2,500 to 3,800 light-years away. NGC 6302 received its name from the dying central star within the nebula. The star is exceptionally hot, and shines brightly in ultraviolet light. The gas wings of the butterfly are about 20,000 degrees Celsius, 36,000 degrees Fahrenheit, rushing across space at over 965,000 kilometers, 600,000 miles per hour. Another Hubble image shows a blue light stream of electrons and other subatomic particles at the center of the M87 galaxy. Particles, attracted by a huge black hole, accelerated to velocities near the speed of light. A monstrous black hole at the center of M87 swallowed up matter 2 billion times the mass of our Sun. The image of the pillars of creation in the Eagle Nebula is considered a symbol of our universe's beauty. These heavenly pillars of clouds of gas and dust look like they have been created by some higher power. Their bizarre silhouettes are illuminated by intense ultraviolet radiation from young massive stars that have accumulated around the pillars. Meanwhile, the cocoons inside the pillars, hidden from our view, are already forming new stars. And these four incredible space objects were discovered by Hubble almost simultaneously. The telescope captured a very tadpole-like galaxy, UGC 10214, 400 light-years away from Earth. Approximately 100 to 200 million years ago, the galaxy collided with a smaller neighboring galaxy and stole from it a long tail of stars and gas. The tadpole galaxy floats across space with 6,000 other galaxies in the background. Another image shows a spectacular collision between two spiral galaxies dubbed the mice. Eventually, they will merge. And the same fate awaits the Milky Way and the Andromeda Galaxy. Closer to Earth, Hubble imaged the amazing Cone Nebula. It looks like a rocky mountain peak, like a giant space mountain. Of course, instead of solid rock, it consists of cold gas and dust. Hubble has even peered into a celestial maternity ward called the Swan Nebula or M17. The illumination comes from the formation of stars, where the seeds of planetary systems are hidden. The bright lights in this image resemble the lights of a night city. This is what the galaxy cluster Able 370, located 4 billion light-years away, looks like. Entangled among hundreds of galaxies in this interstellar nursery are mysterious arcs of blue light. They were created by light-distorted images of the most distant galaxies, located behind the bright ones. They are too faint for Hubble to capture them directly. But the cluster's gravity acts like a huge lens that magnifies and stretches images of background galaxies. Something similar can be seen in a house of mirrors. Due to the effect of gravitational lensing in the cluster, numerous copies of almost 100 distant galaxies have appeared. The most stunning example is the Dragon. There are several duplicated images of this spiral galaxy stretched along an arc. The following image is unique in that it largely confirms the existence of mysterious dark matter. For astronomers, this picture is priceless. The cluster of galaxies CL0024+17, which lies 5 billion light-years from us, is surrounded by a mysterious ring-like structure. Scientists believe that a long time ago, there was a collision between two gigantic clusters. During such an event, clusters of an enormous size cannot be held together by the gravity of their own stars. So this could be dark matter which eventually clumped together and formed a ring. Usually, dark matter, consisting of elementary particles still unknown to science, is invisible. But distant galaxies in the CL0024+17 cluster illuminated its cloud with their radiation. And finally, you will see what the universe really looks like. In 1995, astronomers decided not to aim the telescope at a galaxy or a star as they would usually do. This time, they chose a piece of dark sky over the constellation Ursa Major as their target. Make a circle the size of a dime with your fingers and look up through it. This is the field of view Hubble had at the time. And this was enough for the telescope to make a revolution in astronomy. Hubble was able to detect over 1,500 galaxies at various stages in their evolution. Some of them probably formed at the beginning of our universe's formation. This is how the Hubble Deep Field was created. But it didn't end there. In 2004, based on the first version, the Hubble Ultra Deep Field image was made, containing an estimated 10,000 galaxies. The snapshot contains galaxies of various ages, including the most distant red dim galaxies. Scientists believe they were born during the infancy of our universe when it was just about 800 million years old. Then in 2012, astronomers unveiled the Hubble Extreme Deep Field. It was assembled by combining 10 years of the telescope's data. Over 2,000 images, containing even dimmer and more distant galaxies than before, were taken by the near-infrared camera and the advanced camera for surveys. Later, even more galaxies were added to the image. Will Hubble be able to further improve its picture of the universe? Nobody knows for sure. The telescope is old. In the summer of 2021, it went offline for a month due to a failure of the main computer, and after a few months, there were problems with the synchronization of internal messages. But the problems were fixed from Earth. The observatory has also been repaired and upgraded 5 times in space. But even though it is in low orbit, no further missions are planned. So there will be no one to repair the telescope in case of a malfunction. But even without serious issues, it can still fall back to Earth. During previous Hubble maintenance missions, scientists equipped the telescope with more tools, such as ACS and NICMOS cameras. So with age, this piece of machinery gained about 1,350 kilograms, 3,000 pounds, in weight. The excess weight and the state of free flight gradually shorten the orbit of the observatory and bring it closer to the Earth. To prevent a catastrophe, astronauts prepared a device to decommission the telescope. If necessary, it will be allowed to deorbit and fall into the Pacific Ocean. Or, it could be sent deep into space. But for now, no one is in a hurry to say goodbye to the unique telescope. Engineering research gives Hubble a chance to keep functioning until 2030 to 2040, even without repairs. If this is the case, Hubble will have time to work in tandem with the next-generation James Webb Space Telescope. Webb is able to observe the universe in infrared light, but Hubble is stronger in the optical and ultraviolet range. Both telescopes would be able to study the same objects or phenomena from different angles. But no matter how events unfold, Hubble's groundbreaking images will never be forgotten. The telescope has allowed us to see galaxies at all stages of their evolution and discovered protoplanetary disks, distant stars, exoplanets, and black holes. It showed that space is not empty and black, but bright and full of celestial bodies. Hubble even did the impossible. It sent us to the universe as it was 13.4 billion years ago. Did you know that right now, while you're watching this video, a huge eye of the telescope is watching the depths of space from the Earth's orbit? And you can even join it on Space Telescope Live right now. You'll find the link in the description section. We hope you enjoyed the video. Let us know what you thought about it in the comments. And make sure to stay tuned here for more exciting stuff from our universe. Thanks for watching Dark Core.